Okay, so part B was to find the local extrema. So we're going to learn later in this chapter another way to find the local extrema without the closed interval method. But for right now, to find the closed interval method, you can just use step 3 from the closed interval. How you would do that? Well, I'm going to rewrite this. F of negative 1 is equal to 37. F of 0 is equal to 0. F of 1 is equal to 5. F of 3 is equal to negative 27. And F of 4 is equal to 32. Okay? So now what I'm going to do is I'm going to look at these y values. When I went from 37 to 0, my function went down. And then when I went from 0 to 5, my function went up. So that means it created something like this, which would then be a local minimum. And this local minimum occurs right here. Also because f prime of 0 is equal to 0. So the local minimum is going to be at x equal to 0. And if I ask for the local minimum value, it would be f of 0 equals 0. Now, as I continue on, well, from 0 to 5, the function went up. And then 5 to negative 27, the function went down. So it created a curve like this, which then means that it's a local maximum. So it went up from 0 to 5, and then it went down from 5 to negative 27. So what is in the middle? This part right here. So we also know that f prime of 1 is equal to 0. Remember that local extrema, the derivatives have to be equal to 0 or does not exist. So I have a local max at 5, and at 1, and it has a y value of 5. So I have a local max at x equal to 1, and the local max value is f of 1 equal to 5. And then I will do this again. I will go from 5 to negative 27. I know it went down. And then from negative 27 to 32, the function went up. And so it created this. Therefore, that is a local minimum. F prime of 3 we know is also 0. So we have another local minimum value at x equal to 3. And local minimum value is negative 27, which is the same thing as saying f of 3. Okay? And that is part B. So all you have to do is look at these and find out what is happening to the graph, up or down. And as you're doing that, find out what would be, where is it dipping or where is it peaking, and that would be your minimum or your maximum. Okay? All right, and then the last one, part C, is to graph. Okay, so all I do actually is use the values of these points and then just kind of connect. So I'm going to sketch my graph here. This is going to be negative 1, 0, 1, 2, 3, and 4. Now, I have quite large y values. They go all the way from 37, 32, and negative 27. So I will make each one of these 5. So this will be 10, 20, 30. Is it more than 30? Yes. 40. Okay? And then negative 10, negative 20, negative 30. All right, so I will just start plotting my points. So negative 1 is going to be negative, it's positive 37, so 37-ish, right about here. 0 is going to be 0. 1 is going to be 5. And 3 is negative 27. And 4 is 32. And then I will try to connect this with a nice smooth curve. So I've got this and this and this and this. Okay, and we're doing a closed interval. That's why there's endpoints here. There's no arrows. All right, so by looking at the graph, we can see that absolute max occurs here, that this right here is a local minimum. This here is a local max. This here is an absolute minimum and an absolute, and a local minimum. And this right here is not a minimum or a maximum. It's nothing special. It's just a point. Okay? And this graph matches up with the information that we came up with in our previous steps. All right. Good luck to you.